Hi and Assalamualaikum everyone. My name is Patricia Shazuna binti Sharudin. My matrix number is CE240045. Today I would like to talk about question 1A. Okay, from 1A that they been given differential equation for dy per dx equal to 3y minus x squared y. So, firstly they want us to show the equation to be solved by separation method. So for the separation method, firstly we need to separate y and x. So the first step that I do is I factorize for y, so it will become dy per dx equal to y 3 minus x squared. So the y will be transferred to the left and then it will become 1 for y dy per dx and equal to 3 minus x squared. So from this equation, to get the solution, the general solution, we need to integrate both parts and then it will become to integral 1 per y dy equal to integral 3 minus x squared dx. Okay, for integral 1 per y dy, we know that it will become to ln y. So the answer will be ln y equal to integral for 3 minus x squared will become 3 will added by x and then minus to x. The power of the x will add as 1, so it will become 3 and then will be divide by 3. So and then when integral the part, we need to add constant, so plus c. Okay, ln y, it will become to exponent ln y equal to exponent, so will be power of 3x minus x power of 3 per 3 plus c as a constant number. Okay, so the solution, the general solution will be as y equal to c constant exponent power of 3x minus x power of 3 per 3. Okay, and then at the part 3, they give particular solution which is y0 equal to 2. So we know that y will become to 2, so we can say it as 2 equal to the general solution from above, CE power of 3, x will be changed as a 0, so 3 multiplied by 0 minus 0 power of 3 per 3, so it will become 1. So we can say it as 2 equal to c multiplied by 1, so 2 will be equal as c, and then the solution, the particular solution, we can change the c as a 2. So take the general solution from above, y equals c will become as 2 exponent power of 3x minus x power of 3 per 3. That's all from me. Thank you.
The solution using MATLAB. For question A1, input. First, we define the equation The script starts by displaying and stating that the differential equation is dy over dx equal to 3y minus x power of 2y, and then it spread the variable of 1 over y dy equal to 3 minus x power of 2 dx. And the second is the integration. The left hand side, if integrate 1 over y dy evaluate to ln y, and then the right hand side is integrate 3 minus x power of 2 dx evaluate to 3x minus x power of 3 over 3, and then the general solution. After the integration, the equation is ln y equal to 3x minus x power of 3 over 3 plus c1, exponentiating both sides if y equal to c1 times exponential 3x minus x power of 3 over 3. And the fourth step is initial condition. Using the initial condition y 0 equal to 2, the script calculates the constant c1, and then the particular solution. The particular solution y equal to c1 times exponential 3x minus x power of 3 over 3 is displayed. And then finally the script defines this as a function and plots it for a range of x values to visualize the solution. And then for the output, when you run the coding, we will get in the command window state that for question A1, we will get step 1 is a separated equation 1 over y equal to 3 minus x power of 2, and in step 2 integrated equation which is ln y equal to 3 power of x, I mean 3x minus x power of 3 over 3 plus c1, and then step 3 we will get the general solution which are y equal to c1 times exponential 3x minus x power of 3 over 3, and then step 5 is particular solution which is y equal to 2 times exponential 3x minus x power of 3 over 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Putra Hafiz bin Azmi. My number metric is CE250085. So I would like to present about question 1B. First, we need to check the exactness of the differential equation of 1 over dx dy equal to y over x squared dx. So first thing we need to change to the form mxy dx plus nxy dy equal to 0. So we got the mxy equal to y and xy equal to minus x squared after we simplify. So partial derivation of mxy equal to y with respect to y. So we got delta m over delta y equal to 1, and xy equal to minus x squared with respect to x. We got delta n over delta x equal to negative 2x. So let's show delta m over delta y not equal to delta n over delta x. 1 not equal to the minus 2. So they show therefore the differential equation is not exact. Okay, that's all.
Here are the script for the solution using MATLAB for question 1b. For the input, we have the script explanation which are the coefficient of dx and dy. mxy, the coefficient of dx defined as y in the script, and nxy is the coefficient of dy defined as negative x power of 2. The equation is written as mxy dx plus nxy dy equal to 0. Substituting the values, we get y dx minus x squared dy equal to 0. And then we will go to the partial derivative. First, we will calculate the partial derivative. Since mxy equal to y, its derivative with respect to y is delta m over delta y equal to 1, defined in the script as dm underscore dy equal to 1. Then since nxy equal to negative x power of 2, its derivative with respect to x is delta n over delta x equal to negative 2x, defined in the script as dn underscore dx equal to alias x minus 2 times x. And then we will go to the display equation and partial derivative. The display the component. The equation is displayed. The equation is displayed as f print f given equation y dx minus x power of 2 dy equal to 0 backslash n f print f mxy equal to y and xy equal to negative x power of 2 backslash n. And then this partial derivative are displayed using f print f delta m over delta y equal to percentage 2f backslash n dm underscore dy and f print f delta n over delta x equal to negative 2x backslash n. And then we will check the exactness. Condition for exactness. For the differential equation to be exact, the following condition must hold: delta m over delta y equal to delta n over delta x. The script checks this condition using an example value of x, example case x equal to 1, and evaluates. In the script, we will get x underscore sample equal to 1 if dm underscore dy equal to dn underscore dx. X sample f print f. The equation is exact since delta m over delta y equal to delta n over delta x. Else, f print f, the equation is not exact since delta m and since delta m over delta y is not equal to delta n over delta x. The key outputs for the script is the equation is displayed along with mxy and mxy. Partial derivative of delta m over delta y and delta n over delta x are calculated and displayed. A numerical check determines whether the equation is exact based on the quality of the partial derivative. This approach systematically verifies the exactness of the differential equation. For the output, when we run the script, we will get in the command window is equation 1b. Given equation is y dx over x power of 2 dy equal to 0, mxy equal to y, and nxy equal to negative x power of 2. Delta m over delta y equal to 1.00, and delta n over delta x equal to negative 2x. And finally, we will get the equation is not exact since delta m over delta y is not equal to delta n over delta x.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muhammad. My matrix number CE240066. So I explain question 1C. Question 1 to us find out plus the bracket 2xy plus x squared minus 1 dy equal to 0. Then we do the first question. So next we differentiate respect to y, then differentiate respect to x. After that, so we compare. After that, get the answer. Then the answer is equal, so the differential equation is exact. So next we find the potential function of xy. Find the potential function. We can use can put the equation d for delta n over delta y equal to delta n over x. We must integrate the condition depend on x. This equation to number 3.
For the solution using MATLAB question 1C, for the input in the script you will get a script explanation. For step 1, define constant and initial condition. For initial value, the script starts by defining the initial condition, which is x0 equal to 1 and y0 equal to 2. To display the initial condition, these values are printed to the console using DISP. Step 1. Define the initial condition. Printf initial condition x0 equal to percentage %d and y0 equal to percentage %d. And then for For step 2, we will define the mxy and nxy, modified terms after integrating factor. The script defines mxy and nxy, which represent parts of the differential equation after applying an integrating factor. Mxy equal to x power of 3 over 3 plus x power of 2y, while nxy equal to y power of 2 x over 2 minus y. Display the definition. These terms are displayed using DISP. Mxy equal to x power of 3 over 3 plus x power of 2 y, and DISP nxy equal to y over 2x over 2 minus y. In step 3, we will verify the exactness. For the exactness check, after applying the integrating factor, the equation is assumed exact. This is stated in the script as a DISP step 3. Verify the exactness. And we will get f the equation is exact after applying the integrating factor backslash n. For the step 4, we'll start by compute the constant c. Using the initial condition, the constant c is calculated by substituting the initial values x0, y0 into mxy plus nxy, and we will get c equal to mx0, y0 plus nx0, y0. And for the display complete constant, the result is displayed as displays DISP step 4. Compute the constant c using the initial condition. F compute constant c using XOYO. C equal to percentage g backslash n c. For the step 5, we will start by construct the implicit solution. Implicit form of the solution. The solution is constructed as x power of 3 over 3 plus x power of 2y plus y power of 2x over 2 minus y equal to c. And the equation that is displayed is DISP step 5. Construct the implicit solution. We will get f print f x power of 3 over 3 plus x power of 2y plus y power of 2x over 2 minus y equal to c. In the step c, this is my means in the step 6. We will start by display step-by-step result. For the integration of mxy, the first part of the equation is x power of 3 over 3 plus x power of 2y. In the script, it is displayed as a DISP step 6.1 integration of mxy. F print f x power of 3 over 3 plus x power of 2y. And then we will go into the integration of nxy, the second part, which are y power of 2x over 2 minus y. The script display is DISP step 6.2 integration of nxy. And finally, we will combine the solution. The full equation with c is displayed as a step 6.3 combine implicit solution with constant. The script systematically solve and present an exact differential equation by calculating the constant c from initial condition and constructing the implicit solution step by step. After successfully run the script, we will get the output in the command window is question 1c. Step 1, define the initial condition. Initial condition x0 equal to 1, y0 equal to 2. Step 2, define mxy and nxy after integrating factor. Mxy equal to x power of 3 over 3 plus x power of 2y. And xy equal to y power of 2 x over 2 minus y. This represents the integrated part of the equation. Step 3, verify the exactness. The equation is exact after applying the integrating factor. Step 4, compute the constant c using the initial condition. Compute constant c using x0, 0, y0, we will get C equal to 2.33333. And for the step 5, we will construct the implicit solution. The implicit solution is x power of 3 over 3 plus x power of 2y plus y power of 2x over 2 minus y equal to 2.33333. For the step 6 is display the step-by-step result. Step 6.1 is integrating of mxy. We will get x power of 3 over 3 plus x power of 2y. For the step 6.2, integrating from nxy, y power of 2x over 2 minus y. And finally, for step 6.3 is combine implicit solution with constant. We will get x power of 3 over 3 plus x power of 2y plus y power of 2x over 2 minus y